Alright, now this video that we're going through right now is just going to be a continuation of the first, where we're going to be looking at the concept check part of it. So this is just a way to sort of sharpen your skills and make sure you understood what was presented in the first part of the video. Now, we already looked at part A and sort of walked through it a little bit in the class, in the previous video. It says consider the solution of sodium, a weak sodium salt, where A minus is the anion from a weak acid. Now, given this reaction, which way will the equilibrium lie? Because of the fact that it says that this is going to be our conjugate base from a weak acid, we know that we're going to actually end up with very, very little of this to work from. So that means that our equilibrium is going to lie to the left. Knowing that piece of information, is the Kb value going to be greater or less than 1? Think along the same lines as we had before with our K values. If we have a weak acid, that means we're going to, or a weak base in this case, are we going to have a large or small value? We have to have a very small value, okay? So it's going to be less than 1. Now, does this mean that since we have a value less than 1, does this mean it comes from a strong or weak base? Well, that means that it also has to come from a weak base because the rest of the small concentration that we're dealing with can only come when we have a weak base. Now, looking at the examples that we have here, it gives a whole new question to actually consider. Acetic acid and HCN are both weak acids. Acetic acid is a stronger acid than HCN. Arrange these bases from weakest to strongest and explain your answer. Taking a look at what we have here, we have water, our chloride ion, cyanide, and acetate. We need to put these in the correct order. Well, considering what we know from slides ahead, we know that the bases, the conjugate base that comes from a strong acid is actually going to be the weakest, going to be neutral. So, in this case, we know that that means our Cl minus. Cl minus is the weakest. Now, from there we now have water, cyanide, and acetate. Well, we know that if it's coming, the conjugate base from a weak acid is going to be much stronger than water. So, Cl minus, then H2O. Now, to figure the next part, we actually get a little bit of a clue from the question. It says acetic acid is a stronger acid than HCN. That means it's going to dissociate more often than HCN will. So that means the next base we're dealing with is going to be our acetate ion. I don't know why I didn't just write the formula. It's okay. We'll go back to that. But that's going to be our C2H3O2, which leaves finally our cyanide ion as our strongest of our bases. Okay? Now, again, understanding how we determine strength is going to be the key to looking at this type of problem. Now, based on what we know, we see that this is actually what we're going to come out to. We know that our KW is always going to come out to 1.0 times 10 to the 14th, to negative 14th. That's not a problem. If we're looking at how water dissociates, we're going to end up with this as our constant every time. So that means our chloride ion first, as from a strong, H2O second, following this line, because this reaction is always going in the background, and our acetate, then our cyanide. Okay? Now, the next question asks us to discuss whether the value of K for the reaction is going to be greater than 1, less than 1, or it's going to be equal to 1. Based on what we know and understand, it's actually going to be less than 1. What do I mean? Well, if I have a Ka value for HCN, which is my reactant in this case, which is 6.2 times 10 to the negative 10, and our HF, hydrofluoric, which is on our product side, which is 7.2 times 10 to the negative 4, this means that the HF, or the hydrofluoric, is what's going to dissociate more often. That being the case, that means that our ratio between the two is going to end up being less than 1. Now, how can we go about calculating these two? Well, what we're actually going to end up doing is just doing a little bit of division. we're going to have our HCN concentration, or Ka, divided by that of our hydrofluoric. And you should come out with a value of 8.6 times 10 to the negative 7. Okay? So in this case, we just did one over the other. And this gave us our value. Now, quick recap, basic definitions. Bronsted, Lowry, and Arrhenius. What makes these things acidic or basic are acid-base strength determined by dissociation. Again, high Ka and Kb values, strong, low Ka and Kb values, weak. Strength of conjugate base is based on strength of the acid, and overall solution strength is determined by the ratio of hydrogen ions to hydroxide ions. So my hope is that you were able to sort of follow along. Everything will work out accordingly. Look back at these videos, review them. In case you have any questions on the logic that was used, please bring them with you to class so that we can answer them and make sure that you are set and ready for this exam. I'll talk to you later and have a great day.